a function. So you are seeing the function. So now we are dealing with NLpp. So at LPP you are seeing variables with power 1, but now the highest power is 2, as you can see, square. So how to deal with this? So first we will find the stationary points, which are wait a second. Yeah, del f by del x 1 equal to 0, del f by del x2 equal to 0. For this, your partial differentiation should be concept should be clear, but if even if it is not, I would try my best to explain that stuff to you. But you know, I don't know if you can count on me on that note. So, in partial differentiation, only the term in the denominator with respect to the variable we are differentiating, only that is taken as variable to differentiate. Others are treated as constants. So constants differentiation standalone is 0, and if they are with coefficient, then only coefficient remains, because there that variable's power becomes 0. So for differentiation, let me tell you, this is it is n x raised to n minus 1, and for integration, which is opposite of it, so it is x raised to n plus 1 by n plus 1. So this is not needed here. So we are going for x raised to n minus 1 here. So we take the equation. So with when we do del f by del x1 equal to 0, we would take x1 square, since we can already find this out here, but let's elongate it for you. So x cube square minus 8x1 minus 10x2 minus 12x3. Yo, what's up, one viewer? How are you, man? I can't see your chats or anything, but if you are doing any chat, then thanks for that, and thanks for coming. So, x1 square, x2 square, x3 square, 8x1, 10x2, 12x3 plus 100. Yeah, this is the equation, right? Yeah. So plus 100. Since it is about del x1, so only x1 variables are treated as variables, others are constants. So this x2 square, this is a standalone constant, like 9 square, it is still gonna be a constant. Like it is gonna be 81, it is still a constant. So constant square, it's still gonna be constant, it's not variable. Since we are taking it as constant because we are only taking x1 as a variable, so this goes away. So we are also gonna take double derivative. So many of the times this is gonna be 0, but it was gonna be more complicated if there was like x1 x2 two terms together. So even after double differentiating, there would have been terms, because one would vanish, one term would vanish, but the other would sustain till the end. So yeah, so we are taking only x1 terms because others are constant. We are just gonna rule them out. Like this is also constant into constant, still a constant. So we don't want you. And this is also constant with a constant x3. Nah, we don't give a damn about them. And 100 is still a constant. Rule out. So these all terms are gonna rule out when we are calculating for when we are differentiating with respect to x1. So x1 square is gonna be, let me just expand it for you. So it's gonna be x1 square minus 8x1, like I showed you. I raised there was 8x1 here, so I brought it here for a simplicity. So we are gonna do this f of this del f of then del x1. So it should be, let me show you, if we do nx raised to n minus 1, so it will be n is this stuff, x raised to n equal to n x raised to n minus 1. I didn't write that stuff here, so sorry for that. So n x raised to n minus 1. So this would come here, right? N x raised to n minus 1, so 2 minus 1. It is 1. So it is 2. 1 we don't write, so because it is the same thing. Like if I give an apple to you one time, then you get that same apple only. You won't get double or triple the apple because I give you once. Because square means, like multiplication is repeated addition, square is repeated multiplication of itself. So like 2 square is multiplying 2 times with itself. So, yo, 15 folks. I really appreciate that. Thanks, man. Thanks for coming. So, yeah, 2x1, and here it is already x1. So, this power is going to be 0. Do I need to even explain it? See, because, because it's as clear as day that I have to put, let's just take out 8 out of the picture. 8 is gonna be when you have coefficient, so 8 is gonna be outside. We are gonna deal with this, and at the end that 8 is gonna multiply just simply. So n is 1 here, so nx is to n minus 1, so 1 is gonna come here, nx, and 1 minus 1, because n minus 1 nx raised to n minus 1, so n minus 1. Oh, thanks for the like. Someone liked my video. Thanks, man. I really appreciate it. I'm really grateful for that. Thanks, man. You made my day. So 1 minus 1, it should be 0. So anything raised to 0 is supposed to be 1. So 1 into 1, it's still 1. And when you multiply something with 1, it is the number itself. Because 1 is multiplication identity. It retains the number itself. Because you add any number once to itself, I mean, you just means add that number itself once to avoid, then it would be still that number itself. Oh, two people liked. Thanks, man. I really I am grateful. Thanks, man. Thanks for real. I really appreciate it, bro, from the bottom of my heart, man. Thanks, man. That really means a lot. So 2x1 minus 8. So this is the answer of uh, you know del f by del x1. So x1 equal to minus, okay, minus becomes plus because we are transposing from LHS to RHS. So its sign changes means we give opposite sign, plus 8, because let me give you an example. If you borrow money from me, then on your side you are actually gaining money. I am losing money, you are gaining money. So these are two opposite sides. If here 8 was getting reduced, so here 8 was getting gained. So if I have to do that, I have to balance and I have to give opposite signs to take this here. So it is plus 8. Simple. Transpose. So now here it was multiplied. So opposite, here it gets divided. It's 4. X1 equal to 4. Stationary points. So now let's do that same with x2. So now I would do it a little fast, like I would reduce explanation a little. So how it goes. So since we are taking x2, with respect to x2 we are differentiating, so other terms we don't need to consider here. But the only time you need to consider x2 terms is when there is x2 terms with other terms, then both the terms might appear because they are going to be treated as constants. Yo, two people watching, bro, still now. Thanks, man. You are really great. I hope your day goes good. So, yeah. So, where we were? Yeah. So, del x2. So, del x2. So, we would this time, since it is not complicated sum, since there is no different terms together, it would have sustained in the differentiation too if there were two terms together, but it is not till now. That would have been a different case, but now only x2 term we have to consider. So in x2 term we have only plus x2 square and minus 10x2. So x2 square x2 square minus 10x2. So as last time, Since it is x2 square, its differentiation would be x 2x2, since the square would come here and square would become 2 minus 1, so it's 1, so it becomes nothing, vanished into void, nothing. And since its power gonna be 1 minus 1 0, 1 minus 1 0, so it's gonna become 1, the whole thing is gonna become 1, so it's just the constant itself, so equal to 0. So x2 equal to 5, I guess, so because it's gonna be 10 by 2, it's 5, and here we go. Sorry if this is a little fast, you can tell me in the comments if this is a little fast, but till then I guess you're comfortable with the pace. Since x2 equal to 5, 4, and we have only one more to find out, so to find another one, now this time we have x3, only x3 terms, x3 square, 12x minus 12 square. I'm already seeing the solution. It must be definitely like 6 or something. So stationary points are 4 5 6, I guess. But yeah, 12x cube, and this is every time it's gonna be 0, but because it is clearly a constant alone, so it's gonna be 0 definitely. So yeah, 100 is a constant, right? So uh, and derivative of a constant is always 0 until it is a coefficient. Yeah, so also even the coefficient goes out maybe, or something happens. Only coefficient remains, the variable goes out actually if variable is there, or reduces its power. That's how it is. So coefficient always comes in front in sorry, the power comes in front as coefficient, coefficient remains as it is, and the variable reduces its power to 1. That's how it works. So x3 square minus 12x3, so this becomes 2x3 minus 12 equal to 0. So x3 equal to 12 minus 12 by 2 equal to 6. Here we are at the answer. So this is 6. I told you it must be 6. So after this, since stationary points are all positive, like these are all positive, if it would have been alternate like negative positive negative or positive negative positive, these two cases it would have been z would have been maximum, okay? But in this case we have all three positive, so this is z is minimum, so we are not gonna get z maximum, you're gonna get z minimum. So okay, not exactly, not here, but yeah, this rule is not, it is not applied here. It is after we apply it after Hessian matrix. After we find Hessian matrix, I'm going to show it to you. After we find Hessian matrix, it is z minimum or maximum, then we're going to apply this to the z, so let's find out Hessian matrix. So for that matrix, here we go, and we're gonna find its minors, then its determinants. Its minus determinants, so it's gonna all be in square form. So first we're gonna go, so like you understand that, right? First we will take x1, then we would use all three. So we are gonna take x1 x2 x3 in all three columns, and we are gonna just each time to see. So we have to take square derivative. So with respect to are gonna come in two times. So if two times it is gonna come by permutation combination, since we have three variables, but we have uh, two two times they are gonna get multiplied, so they can be multiplied in various combinations, but the number of combinations that is gonna be, so we're gonna find it by permutation combination, so that is gonna be 3 raised to 2, sorry, wait a second, yeah, 3 raised to 2, which is 9 elements. So 9 elements are gonna be there. So yeah, let me show you. Like, come on, you would be knowing permutation combination formula, right? NCR stuff, like here this is 3 or something, and here this is 2 or something, and something happens, n factorial by r factorial into n minus r factorial, I guess. So here 3 by 2 into 2 factorial, which is 2, but yeah, into 3 minus 2 factorial n minus r, yes. So 3 factorial is 3 into 2 into 1, and 2's factorial is always 2, because 2 into 1 it's still 2, and this is gonna be 3 minus 2, it is 1's factorial, still 1. So yeah, 1's factorial is 1. So 3 into 2, so 2 gets cancelled. So 3 remains or something, okay. Yeah, I guess so. No. This is combination. This is permutation formula. This is combinations formula. N by n minus r factorial. Sorry for my mistake. So this is gonna be 1 factorial. So yeah. Nah, I did some mistake, I guess so. Sorry for that. But yeah, it is somehow like that. Okay. I did it with instincts, but permutation combination formula does come in handy. Like, I use probability sample space thing, but that has no logic to explain. So maybe I thought I would explain it in permutation combination technique, but I guess I am getting sloppy at it. Later, that goes later, but I'm just telling you the normal instinct wise formula. I'm saying, like, how many variables you have. We have like 3 variables, and how many times you have to repeat it. So that goes in power, and you would find how many possibilities are there. So we have 3 variables, x1, x2, x3, and we have to multiply them 2 times. So 2, so there can be 9 possibilities of combinations, we can multiply them. So yeah, that's how I found it. So I don't know which, I don't remember which technique I use, but yeah, this is that. So that is some technique. Okay. So x1, first we multiplied with x1, then x1 with x2. Then we use each combinations. Okay. x1, x3, then x2 gets x1, x2 gets x2. By the way, if you don't know, x1 into x1 is x1 square, since they are same things getting multiplied 2 times, so it is easier to write it as square, like it makes your things easy. So x1, x3 into x2, yeah, x2 into x3, and x3 into x3, which is x3 square. So this is how your denominator is gonna be, right? So let me show you how it is. Sorry for the mess, but yeah, I'm trying to raise it. Yeah. So this is how I got this. So there is gonna be square at least in the diagonals, because in diagonals we multiply the same stuff. So yeah, because they are in their position where two multiplied things are same. So yeah, let me write that first. This is the technique you can easily remember this way. It would take time, but yeah. Oh, sorry, this is square. This would take time, but yeah, you would remember, right? So here we go, x1, x2, and here we go, del square f, del x1, del x3. So this is x2, x3. This is del square f, x3, del x2. Yeah, I'm doing it right? Del square f, del x2, del x1, del square. Sorry for my sloppy handwriting, for real. So this is x3 into x1, and we are done here. So this is Hessian matrix. So, and we have to find each one's minors. So that's how we are gonna get derivatives. So yeah, let's go with that. First, let's find the Hessian matrix. So del square f by del x square, del x1 square. So let me explain you how double differentiation works. So Del square, let's take the complicated one, this one, okay? You would understand the rest. Del square f by del x1 del x2. So this works like this, like you would first you differentiate it normally, like we differentiated here, del f by, oh no, we just erased our so simple like solution. We could have used the stationary point solution here, but whatever. And this is slightly inefficient, but yeah, we have to do it again. So mm, yeah, so this is del f by del x2. Then we double differentiate it. We again differentiate it with respect to x1. So the x1 terms, like we differentiate it with x2, then whatever x1 term remains, that would go here, okay, to differentiate. So um, yeah, we're double differentiating. First we differentiate with respect to x2, like x2 terms are getting differentiated. Then if still x2 was a coefficient with x1 terms and somehow x1 terms remain and x2 terms get reduced, but yeah, somehow x1 term related, then they get left to like get differentiated here in x1. Or else in these type of questions where there are no terms together, same different terms together, like x1 x2 term together, there are not in this question. So here only diagonal matrix we would get, because there are still like terms with square as square which are of same number. So same number with respect to differentiation, we would get those, like x1 square, it would be remaining here still here too, because there is x1 till now. So yeah, we would get to that. And let me tell you a trick, like when there is double differentiation, like if these are the things, then these won't remain because their power isn't enough to survive this differentiation. Because this is double differentiation, this will survive till one differentiation because its power would reduce in the first differentiation, and in second differentiation it would become a constant or zero or something. So uh, only take the square terms, they would survive till here. So yeah, if you only have same term multiplied with each other. So this is how you differentiate, okay? First differentiate with respect to this one, then you differentiate with respect to this one, okay? I hope you get it now, but I would still explain you while doing this question. So del f by del x1 we did earlier. So let's do this one. So what was the del f by del x1? It was 2x1, and let me tell you, del f by del x1, it was 2x1. See, 2x1 minus 8, because x1 reduced its power to 0 and 8 only remained, and x1 became 1. So you get it, right? So minus 8. Since we are again differentiating it with del by del x 1, so only x1 term 1 is remaining. This constant will become 0 after differentiating, and this will become 1, like 1 will 1, it has power 1, so 1 here, 2 into 1 is 1, and here power will be 1 minus 1 and nx raised to n minus 1. So this will become 0. So the only thing you have left, so when it is x raised to 0, then anything raised to 0 is 1. So what is remaining? 2. So like that, of every, since every term is similar, like x1 square, x2 square will be also the same, like we have x1 square, x2 square, x3 square. So these are all gonna be like 2 2 2 because they are gonna be double differentiated. So these are all gonna become 2. So 2 2 2, because after double differentiation the square, only 2 term is gonna remain. If there was some different coefficient, like 3x1 square, 4x2 square, then these numbers would have been different, and I would have to calculate them separately, because those coefficient would have multiplied with these two. Because there is no coefficient, nothing is getting multiplied, but coefficient gets multiplied with whatever the differentiation term is remaining. So with 2, that coefficient would have multiplied and the answers would have changed. but there is no coefficient here, so it is the same 2 all over here. And since we don't have different terms, let me show you with one example. Like uh, let me pick one example. Del f, yeah, this one, del square f, del x1 del x2. So here we will take del x2, del f by del x2, then again redifferentiated del by del x1. So let me show you. Like del f by del x2, here only x2 terms are 2x square, x2 square and minus 10x2. So when we differentiate it with this, then this x2 will go because it would become raised to 0. So anything raised to 0 is 1, 10 into 1 is 10. So we get minus 10 here. And x2 square becomes like 2x2 because it would be let me show you 2x2, because here 2 minus 1 became 1, and 1 means this stuff itself, this variable itself. And when we we did this, but now to do this del by del x1, there is no del x1 term, so both of these are constants because we are doing partial differentiation. So only this, what is the with respect to means denominator, any the variable we are using for differentiating, only that term will be treated as variable, others are constant. So this is constant, 2 into any constant is constant, x2 here is constant because with with respect to one x1 we are dividing, so this will become 1, and this is a constant. So sorry, this would become x1 2x2, so 2x2 minus 10, so this is constant, this is constant, so these would be erased, all will become 0. 0 plus 0 is 0, so they won't survive till this because there are no different variables multiplied. If it would have been like del I by del x2, x1 x2 would have been there, then x2 would have reduced to 1 and x1 would have remained, and x1 would have reduced its power when double differentiated, and 1 or any coefficient is there, that would have remained. But now that's not possible. Like if there was like x cube or x cube into x1 sorry x2 into x1 square, then 2 would have remained because no, like x1 would have remained because 2x1 would have remained because x2 would have gone, then as coefficient x1 square would have remained, x1 square, then x1 differentiated with x1 square would have become 2x1. So that's how it would have remained, but now it is not the case. So we have this simple sum, so every other term will become 0. So let's do that. 0 0 0. So this is actually a diagonal matrix where everything else is 0, only 2 is there, so 0 0 0, only diagonal is 2. So let's take minors. Minors is like we are gonna just make it smaller to smaller table. First we will take this one element table, then we will make it two element table, like 2 into 2 square is 4, right? So we are making a square matrix, so we would do square. So the number we have, the number of elements we have, we would take it square because we are making a square matrix. Double the number of that is gonna come, like double, not double, like square of its number is gonna be the element number of elements in the matrix. So yeah, first we will take the smaller minor, then we will take bigger minor, then more bigger minor. So 2 first is 2, then it's gonna be 2 0 0 2, order of 2 matrix, then it's gonna be third order matrix 2 0 0 0 2. Now we would take these determinants. So let me explain you determinant. So 2 determinant is 2, nothing change. Here we have to do 2 into 2, like let me show you. Cross multiplication, and the answers would subtract. Okay, 2 into 2, 2 into 2, minus 0 into 0 is 0. So yeah, let's take it. Still I'm trying, let's see how it works. So 2 into 2 minus 0 into 0. So 0 into 0 is 0. 0 into anything is 0. 2 into 2 is 4. Here we go. So 4 minus 0 is 4. So we have 4 here. 4. Now how to find determinant of 3 order 3 matrix? So this is gonna be take top 3 elements. Let's write this I, J, K. Let's take here what is the first element. 2. Then after taking these 3 elements, you have to like but alternate signs, okay, like minus here 0, this first element, take this, then this first element, plus 0, then this. After this you have to do this process, like see, the element we took like 2, then you have to cancel this row, this column, like it's row and column, like it is a11 represent like first row first column, so first row and first column gets cancelled, so we have to look at others. Then this is the minor, this is the order 2 matrix we catch, and we do the process we did here, cross multiply 2 into 2 minus 0 into 0. Okay, so yeah, 2 into 2 minus 0 into 0. So what we got here, we got here 4. So this, now since it is 0 still, let's do it. Anyhow it was gonna be 0, but yeah, let's go. So if we are taking this element, oh sorry, let me just erase this. 2 0 0 0 to 0 0 0 2, yeah, 0. So this element we are taking, so second row, first row second column, so we are taking this 0 into 2 0 minus 0 into 0. Okay, 0 into 2 0 into 0 into 2 0 into 0, you get it right. So 0 into 0 minus, oh sorry, 0 into 2 minus 0 into 0. So here we go, 0 into 2 0, 0 minus 0 0. So 0 minus 0 0. Now if we take this third element, so third row, wait a second, this became a huge mess right now. Let me clean it, sort of. Yeah, so this third element we are taking, so third row third column, like see this, this is element representation a11. So here this is 1, so this represents row, this represents column number, where the element is, like locating something. Like if you are standing on a table, how would you locate yourself? Like from 3 meters from length and 3 meters from breadth, the dimensions you are standing, you define it by your dimensions, right? So here we are defining by dimensions. So what, we raise this, then what is left? 0 into 0 minus 2, 0 into 2 into 0 minus 0 into 2, still it is 0 minus 0, it is 0, so it is 0. And here we go, 2 into 4 is 8, by the way. 0 into 2 into 4 is 8, and others don't matter because they are 0 here, so they get out. So I hope you understood this one. Like del, if anything we had done, like uh, I showed you, I guess, but yeah. So in determinant we have all positive stuff, then this z is minimum, right? Z is minimum. If it was minus, plus, minus, or alternative stuff, it would have been z max. The rule I had explained before, it was not that, it was this one. So we have all positive determinants, so z min. So z minimum equal to, we would write z minimum. So how to find z minimum? We have to put the stationary points we got, like 4 5 6 here we got from this three equations. We have to put these in this equation of z, then we are gonna get z minimum. So x1 square, so x so x1 was 4, x2 was 5, x3 was 6. So x1 is 4 square plus x2 square, which is 5 square, so plus x3 square, which is 6 square now minus 8 x1. X1 is into 4. X1 now 10 x2, which is 5. Then minus 12 x3, which is actually 6 here. So we put 6 here. Then plus 100. So 10 into 5 is 50. 50 here. Wait a second, let me erase it as whole. Yeah, 50. 8 into 4 is 8 4s are 32. Then 6 square is 36. 25. 16. 4 square 16. 25 is 5 square, and 36 is 6 square. Now we forgot this. 12 into 6 is 72, I guess. So plus 100. Now you have to calculate this. Come on, you can do that, right? Let's do it for you. 50 minus 50. Then this becomes 50. Okay. Then 16 goes from minus 32. This becomes minus 16. Okay. Now 72 is double of 36. So 36 goes minus 36. So now minus 16 and minus 36 are remaining. Minus 16 minus 36. And on positive side we just have 25 and 50. So which becomes 75 actually. Yeah. So 75 minus 36. Come on, you can do that now, right? Okay. I guess you can do that. Come on, bruh. So I hope you understood the thing I told you today. So see ya. Thanks. Like, share, subscribe. See you next time. Peace out. And if you have any doubts, ask me later on.